Okay, the problem asks at what height above Earth's surface is the energy required to lift a satellite to that height equal to the kinetic energy required for the satellite to be in orbit at that height. So let's say this is Earth. It's not a good drawing. I can draw. So this is Earth, and let's say this is the orbit, something like that. It's not to scale, so yeah. So this is Earth's radius, which is, let's say, uppercase R, and then this much is the height above the surface where the satellite is. Now, in order to lift the satellite from the surface to height h, an energy is required, and the question is the energy that is required there will be equal to at what height, at what value of h, that energy to lift the satellite up from the Earth's surface to that point. That energy is equal to the kinetic energy of the satellite at this point. So we have to first find what is the energy required to lift the satellite up from, let's say, Earth's surface. I don't know, let's say this is point A and this is point B. So from A to B, in order to lift the satellite from Earth's surface A to point B, where the satellite will be orbiting around the Earth, an energy is required. And what is that energy? How do we find that energy? That energy will be the potential energy at this point. From that we have to subtract the potential energy of the satellite at point A. So potential energy at point B minus potential energy at point A, that will be the energy required. So we know that the potential energy at any point is G uppercase M times lowercase m being the mass of the satellite. So that divided by, it is negative, that divided by whatever the value of height is. So in this case, at point B it will be R plus H, and at point A it will be just R. So the energy required will be minus Gm m over R plus H minus Gm m over R. That is the energy required to lift the satellite up. So let's just write it there. And now let's find what is the kinetic energy of the satellite at that point when it is orbiting around the Earth. We know that kinetic energy is half mv square, but what is the value of v? V we can find by when the satellite is orbiting around the Earth, it has an centripetal force. It experiences a centripetal force, and that centripetal force will be equal to the gravitational force due to Earth, because the centripetal force is given by the gravitational force. So basically when it's orbiting, the gravitational force, which is Gmm over R square, or let's say R plus H, just the total distance, that will be equal to mv square over R plus H. That is the height at which the satellite is orbiting. Because since this is R plus H, I have written R plus H. Usually we when we write the formula, we use lowercase r to denote the total distance from the center, but in this case I have written R plus H anyway. So from here we can find the value of V. That will be, V will be Gm over R plus H square root. That is the velocity at any point. So the kinetic energy will be then half m times v square, which will be Gm. We have to just get rid of the square root, so that will be like that. So this is Gmm over 2r plus h. This is the kinetic energy when at the point where it is orbiting around the Earth. So this energy will be equal to that energy. So I will just rewrite this thing, Gmm over r plus h minus now becomes plus, because there was minus here, and minus here, getting rid of the bracket, so that is GMM over R, and here we have GMM over 2R plus H. Now what we notice is the denominator in each of the terms are the same, so we can divide both sides by GMM. If we do that, we end up with this one, plus 1 over R equals to 1 over 2R plus H. So what I will do, I will take this one on the other side because they have the same denominator. So this is there, and then this is 1 over 2R plus H plus, this is now becoming plus 1 over R plus H. So once we do the addition, it becomes 2R plus H here, and this then 1 plus 2, so that's 3. So this basically is a half R plus H, half 1 over R plus H basically, plus 1, so it is 3 over 2 basically. So this is 1 over R, 3 over 2, and then R plus H. It's obvious from here as well because this is half and this is 1, and times 1 over R plus H. So this is now becoming 3R, and then 2R plus 2H. So we need to find the value of H at what height, because that's the variable here. R is Art's radius, that's not a variable. So 2H here, and this is becoming 3R minus 2R, which is R. So we see that H is becoming R over 2. So R is Art's radius, which is 6371 kilometer. So height will be half of that. So that is the height at which this condition satisfies, which is the kinetic energy at this point will be equal to the energy required to lift the satellite from point A to point B, which is that point.